Hello, am I audible? My name is Abhishek Chitnis. Hello, my name is Abhishek Chitnis.
आमचा आवाज नाही येत ना?
नाही, तुमचा नाही येत आहे. अच्छा. Okay, welcome everyone. Good evening. My name is Abhishek Chitnis, and I was doing research at BRC. In my PhD, my work was mainly based on solid state physics, and I was also doing some research on astronomy. We have published one paper which is on eclipse, and in this event, I'm going to share you with few basic things about eclipse. So as we know, on 25th of October, we are going to see one beautiful eclipse from Mumbai. We are going to see the partial eclipse. So let us start the PPT. Okay, so I hope this screen is visible to you. Okay, so the name of this session is Eclipse, the Game of Shadow. In Marathi, we can see Grahan ha खेळ सावल्यांचा. So here beautiful pics you can see on the screen. Before starting this eclipse, let me introduce few basic concepts which are actually necessary to understand the eclipse and eclipse related phenomena. The very first one, here you can see the shadow, the beautiful game which we generally play with our kids. So here two types of shadows are visible. One, the darker one, the innermost part, which is darker most, this is known as umbra. The name is umbra. And if you see over here, I hope you are seeing my cursor. So this shadow over here, this is relatively less darker and which is known as penumbra. So two types of shadows we have to remember, because we are going to deal with these two types of shadows. So let me go ahead. One more concept is there. This is our regular game. Okay, when we were kids, we used to cover the whole tree, the whole house, or the whole car with one thumb or one finger. Now, the question is, this thumb is so small and the car is so big, still we can block whole car with a thumb. And why is it so? The answer is over here. Suppose we are looking at particular object. This is diameter of the object. So this is our eye. So from eye, we are going to draw two lines, two imaginary lines. One is at this end, second is at this end. Now, you can see the angle subtended by these two lines. So the angle between one edge of the object to the eye and eye to another edge of the object. So this whole object is covered with this much angle. This is known as angular diameter of given object. Okay. And this one is the real diameter. So let us go ahead. What is the angular diameter? So angular diameter or angular size of an object is the angle the object makes as seen by an observer. So if you go away from the observer, the obviously angle will decrease. If this object comes closer to the observer, the angle will increase. Now, what is relevance of these two phenomena with our eclipse is shown over here. Now, if we see the moon or sun, we can observe that the angular diameter, the actual size of sun is too big compared to the moon. But since the sun is far away compared to the moon, the angular diameter, angular size of this moon and sun is approximately 0.5 degree. Okay, it changes a little bit here and there because as we know, the sun and earth, moon and earth, both are moving in elliptical paths. So sometimes they are far away and sometimes they are closer. So, but more or less, it is 0.5 degree. So I repeat, although sun is too big compared to the moon, since it is far away from us, the angular size, this angle subtended by moon or sun is approximately 0.5, and this is the key point behind this eclipse. Okay, so you have to remember this angular size of sun and moon is not exact, sorry, approximately equal. So now let us start with this eclipse. So few important points, let me tell you. The first one is, an eclipse is an astronomical event that occurs when one celestial object is any object which is in sky, like suppose moon is blocking sunlight which is falling on moon, or suppose sunlight is falling on earth, but moon is blocking the light. So in this cases, this game of shadow is nothing but is known as eclipse. The second one, uh, since celestial bodies move in circular motion, although we have mentioned over here circular motion, in reality they are moving in elliptical path. So for simplicity, we are going to consider more or less circular motion. So they're always eclipsing each other. So this is very general phenomena. So two types of eclipses we always see. The first one is solar eclipse. The concept is very simple. Whenever moon comes in between sun and earth, it is known as solar eclipse. And whenever earth comes between sun and moon, it is known as lunar eclipse. So basically, we see shadow of moon falling on earth in the case of solar eclipse because moon is blocking the light, and shadow of earth falls on moon when lunar eclipse happen. And two more things, a solar eclipse can happen only on new moon day, a lunar eclipse can happen only on full moon day. So these are few important points about eclipse. Let us start with types of eclipses. So first is solar eclipses. So actually there are four types, but these are three major types. So first one is partial solar eclipse, in which you can see this orangish part is nothing but sun, and whatever black thing you can see blocking this sun is nothing but moon. So is moon visible on new moon day? Answer is yes, you can see moon on new moon day on the day of eclipse. Here, the second one is total solar eclipse. So this disk is actually moon blocking the sun. And this one is annular solar eclipse. So this ring part is nothing but the peripheral region of the sun, and the central disk-like thing is nothing but moon. So these three types of solar eclipse we can see in general. And three lunar eclipse. The first one is penumbral. The penumbral lunar eclipse means whenever moon enters into penumbra shadow or penumbral shadow of earth, we call it as penumbral lunar eclipse. Second is partial lunar eclipse, and third one is total lunar eclipse. So this partial and total lunar eclipse is happening when moon is more or less inside the umbra region of earth. The second thing, so this is the general terminologies. The first one, this is the sun. This is, say, any object, say moon, and here we are standing. So this darker region is nothing but umbra shadow of moon, and this little bit grayish region is nothing but penumbra shadow of moon. Now here the focus is happening, and if you go away from the focus, so this is also similar to umbra, but it is known as antumbra shadow of moon. Okay, so in first region, if the observer is present in first region, this is the region A, then it is known as total solar eclipse. Okay, so whenever earth is moving or earth is passing through the shadow of moon, and suppose it is passing through this region A, so that time you can observe total solar eclipse. If it is passing through B region, if it is passing through this B region, you can observe annular solar eclipse. So I repeat, annular solar eclipse is the third part. Okay, so in second case, if observer is present or standing in this region somewhere, anywhere in this region, you will see annular solar eclipse. In the third case, if observer is standing in C region, here or here, again, here or here, you will see, there's some mistake. It should be partial solar eclipse. Okay, so I repeat, A, total solar eclipse, B, annular solar eclipse, and C, partial solar eclipse. Now, few important phenomena. Whenever you are observing, whenever you are saying that moon is revolving around the earth in circular path, it is not exact true. In reality, moon is revolving in elliptical path and it is wobbling also. So what is wobbling, that I'll explain later. So very first thing is, what is this elliptical path and what is the distance? The closest approach of moon is nothing but 3,63,300 kilometer. This distance or this point is known as perigee, and the farthest point, the nearest point to the earth is known as perigee, and the farthest point is known as apogee. So the distance of moon when it reaches to the farthest point is approximately 5,500 kilometer. So what do we actually observe when the moon reaches at perigee or apogee? So in the case of perigee, the size of moon is say this much, and in apogee the sign is this much. Now question is it really visible? Answer is it is visible, but it is not noticeable for our naked eyes. Okay, so if you are extremely good observer, then only you can relate these things. Otherwise, with photographs you can easily see these things. Okay, I repeat, whenever moon reaches at perigee, the size is this much. I mean, this is this comparison of size, and these are real photos. And whenever moon reaches at apogee, the size is this. So you can see the difference in sizes. Okay, so diameter changes. I repeat, this is not noticeable with our naked eyes easily. Next is this. So this dark one is the orbit of Earth, and this green is orbit of Moon. So whenever Moon is coming in between Sun and Earth, so you can see two types of shadows over here. The yellow one is, I'm just blinking the shadow purposely. So this yellow one is the region of umbra, and the remaining part over here around it, the very faint yellow line is there. So remaining region is penumbral region. So if observer is present in umbra region, he can observe total solar eclipse, and if he is present in penumbral region, he can see the partial solar eclipse. So I repeat, whenever whenever moon passes in front of Earth, and suppose it is exactly in between Earth and Sun, so you can see the dance of shadow on the surface of Earth, which is nothing but eclipse. So this is just a comparison from Earth. So here the moon is near perigee, and here the moon is near apogee. So whenever it is near perigee, you can see total solar eclipse. Whenever it is near apogee, you can see annular solar eclipse. So while observing the eclipse, if you are seeing the totality, you can guess that it is close to the Earth. If you are seeing the annular solar eclipse, it means that moon is at apogee point. Okay, so let me continue. Now the fourth type is hybrid eclipse. So hybrid is not the fourth type of eclipse, I would say. It is like mixture of annular and mixture of total solar eclipse. So from few places you can observe a total solar eclipse. So I'll explain the phenomena over here. See, the Earth is spherical. So if moon is near the line of joining moon, sun and Earth, so there the distance is less, but the same moon, if it goes a little bit ahead, and suppose you're present over here, so distance from moon is more. So here you can see annular solar eclipse. So this is the total solar eclipse. You can see as moon is going a little bit away or ahead. So a person who is standing over here, he is on the line of that ecliptic line. But since the distance is more, distance of moon from his location is more, he can observe annular solar eclipse. So on the same day, in the small time gap, you can observe annular as well as total solar eclipse. So this type of eclipse is known as hybrid eclipse. So from few region you can observe total solar eclipse. From like further region you can observe annular solar eclipse. Now, so question is, why can't we see like solar eclipse on each new moon day or lunar eclipse on each full moon day? The answer is here. You can see the Earth's orbit and moon orbit. You can see some tilt of moon orbit, and the tilt is about 5 degree. Okay, so generally this is not so much, but this causes the effect of eclipse. Eclipse is not happening on each new moon or full moon day. So here, one graphic is made. Now you can see this is the moon. This one is new moon, and this is the full moon day. Suppose moon is present between sun and earth, but it is little bit above or below the earth's orbit, then the shadow is falling either above or below. So here you can see the new moon day is over here, and since the orbit of moon is tilted, the shadow of moon is not exactly falling on earth, it is little bit below the earth. And in this case, even this is new moon day, the shadow is not exactly falling on earth, it is falling little bit above. So in this case, or in this case, you can't observe solar eclipse on new moon day. Similarly, suppose moon comes on the opposite side, so this is full moon day, so this sunlight is falling on moon and reflecting back on earth, but since the orbit is tilted by 5 degree, the shadow of earth is above this moon, so you cannot see the shadow falling on the moon over here. And similar over here, the moon is little bit above the earth, so shadow is not falling on the moon, it is little bit below. Since it is full moon or new moon day, but shadow is not falling on the object, you can't see any kind this ecliptic effect, ellipse effect, the shadow effect. Unlike these two cases, in this case, the moon is exactly the tilt is arranged in some way, so that the shadow is exactly falling on the earth over here, and this is where you will observe solar eclipse. And in this case, when moon reaches to the other side, so this shadow of earth is falling exactly on moon, or you can say moon is passing through the shadow of earth, so this is nothing but lunar eclipse. So here and here, in these two cases, lunar eclipse is happening, but in this and this case, since moon is either above the shadow or below the shadow, or earth is above the shadow of moon or below the shadow of moon, you can't see eclipse. Okay, so these are two cases, this one and this one, which are favorable for eclipse, and these two are non-favorable conditions for eclipse. So I would say, due to 5 degree tilt, although moon comes somewhere between earth and sun, the actual location is little bit above or below than the line of joining this earth and sun, this one. So since moon is not present exactly on the line of sun and earth joining, so the shadow is not falling on earth, and you cannot see the solar eclipse on each new moon day, and similar reason for full moon day. Okay, I hope this is understood. So this is, you need to visualize little bit, otherwise this is easier. This is the animation of the shadow is moving through the earth. So you can see the animation. I'm just playing it one more time. So this black dot moving is known as umbra, and the remaining region is penumbra. So you can see partial solar eclipse from remaining region, but if you are on the line, you can imagine this line, imaginary line, traces by this black dot. If you're present on that line, you will be lucky enough to see the solar eclipse, total solar eclipse. And if you are somewhere outside of this black dot, you will be able to see the partial solar eclipse. So this is just an animation. Now question is, how fast this shadow moves? So see, different researchers have predicted different conclusions, I would say, with their calculations. But in general, the most believable conclusion is it is around 2500 kilometer per hour. So it is too fast. Okay, so if you see different research paper, few research paper have predicted 3500 also. So here I would say it is around 2000 to 2500 kilometer per hour. So here you can see the dark patch on the earth. So this is central region is nothing but umbra, and this peripheral region is nothing but penumbra. So this is the real photo of moon shadow on the earth. So sorry, this one. Okay, so this is just highlighting. So let us go ahead. I hope everything is clear about the solar eclipse, like three types of solar eclipse and all. Now, which prominent things do we see when we observe solar eclipse? So the very first one is this beautiful image is nothing but sun is fully covered with moon, and this region, this white glow, is nothing but solar corona. So you can see solar, you can see its solar atmosphere, which is visible only during the solar total solar eclipse. So during totality, you can see this corona, and believe me, it is beautiful. Okay, I mean, you cannot see complete darkness during the total solar eclipse because of this corona, right? And the second thing is prominence. So here you can see some prominences. These are solar flares which can be observed mostly with telescope. And if it is strong enough, you can easily see the solar flare during the solar eclipse, total solar eclipse. The second one is Belize beads. So Belize was a scientist. So he has predicted, he has observed these things. I mean, this is easy. You can observe this very easily. So as we know, the moon, the surface of moon is not fully smooth. So you will see many craters ups and downs over here. So whenever totality is happening, so just before happening the totality and just after the totality, you can see lights coming from those ups and downs, which are craters, I would say, on the moon. So the sunlight which is coming or passing through that ups and down can be called as a Belize bead. So you can consider these beads. I mean, he has considered these things as a bead-like structure. So just a name is given. So you can see this twice. One is while covering, and second while opening the total solar eclipse. This is another beautiful phenomena. This is known as diamond ring. So this coronal region over here, this peripheral region, can be considered as the ring part, and this is the central diamond. So this is also amazing phenomena which can be seen only during the total eclipse, total solar eclipse. Now there are few technical terms related to this Belize beads and diamond ring, which I'm not um, discussing now. If you have any doubt, you can ask during the section after this session. Now this is a real photo taken from Norway. So you can see over here, sun is covered by moon. And as I said, see, there are many misconceptions with the total solar eclipse. So few people consider that when total solar eclipse happens, so for those 3-4 minutes, the whole sky is completely dark. So the answer is not like that. The sky turns to be a little bit orangish and darker, of course. It is similar to like the after sunset, you can see the dew light for few minutes, okay, like 20 minutes, 30 minutes. So the situation is similar to that. But of course, few brighter stars or bright planets like Jupiter and Venus can be seen in the sun. And this is here cursor I'm taking. So this dot is nothing but Venus. Okay, so this is a real photo. So just to encounter with this misconception that we see the complete darkness and all, I'm showing this photo. So after solar eclipse, the second thing is lunar eclipse. So what is lunar eclipse? The concept is same. We have two types of shadows. One is umbra, second is penumbra. But now, since this is lunar eclipse, the shadow of Earth, the moon is passing through the shadow of Earth, or the shadow of Earth is falling on the moon. So whenever moon is entering into penumbral region, frankly speaking, there is some drop in intensity, but you won't see much difference once it enters into penumbral region. Of course, you can see the drop in intensity, but as soon as it enters into umbra region, you will see the drastic change in moon. Okay, so which kind of change you will see, that I'll show with animation. But before that, I would like to tell you a few things. First is Earth is covered with a thick atmospheric layer. Unlike Earth, or in contrast, the moon does not have any atmosphere. So as we know, while sunset, we can see the sky is reddish, the horizon is reddish. The reason is there is one concept, the Rayleigh scattering. So whenever white light passes through the atmosphere, so gas molecules or the dust particles scatter the light. So scattering the light is like white light is uh, getting separated into 7 colors like violet to red, and the spreading of this violet is maximum, whereas the spreading of this red color is minimum. So these are two photos taken from one animation. So here you can see the sun, and here these two dashed lines are indicating the atmosphere. So whenever sunlight is passing through these two dashed lines, which are indicating our atmosphere, so while passing through this atmosphere, it is the white light is getting separated into 7 colors. So here, the most prominent you can see bluish one. Okay, I repeat, this is animation, not I mean a photo from animation, not the real one. And here you can see the bluish one. Then reddish, uh, yellowish, orangish, and greenish, yellowish, orangish, and reddish. Similarly, over here, the maximum scattering, the maximum spreading is happening with blue light or violet light, then lesser for green, even lesser for yellow, then orange and red is least. So you can see in this region, most of the red light is, I mean, in shadow region, you will see most of the red light rather than completely darkness. So here also the same animation. The sun is behind this moon, and we are looking at the Earth from moon. So this type of imagination is made over here. So you can see blue light is going in space, but red light is coming towards us, and this is the result of this. So whenever moon enters over here completely into umbra region, instead of seeing complete darkness, we could see the reddish moon. And this is the reason that in Umbra region, the shadow of Earth, okay, the Umbra region of Earth, in that region, uh, you won't find complete darkness. You will see red color because of scattering of light due to Earth's atmosphere. I repeat, whenever sunlight passes through the atmosphere of Earth and it is going ahead towards moon, so that time light gets scattered, or you can say light spreads in 7 different colors, and red color is prominent in the darker region, umbra region. Hence we will see that red light is reflecting from moon, and we can see moon reddish. Here you can see the partial lunar eclipse. So like half of the earth, half of the moon is in dark region, that is umbra, and half of the moon, I mean remaining part, is in penumbral region. And as I said before also, if a moon enters into penumbral region, you won't see complete darkness or the partial lunar, you won't see partial lunar eclipse over here. You will see the drop in intensity of moon. Okay, so these three effects we can see in lunar eclipse. So I'll just run this animation. So this, the central circle is umbra, and this peripheral, the outer one, is penumbral region. So this much is penumbral, and this full grayish is umbral. So as moon is entering, drop in intensity, then you can see here partial, and it is completely outside. So whenever it is entering into the central region, you can see the reddish color because of scattering of white light due to Earth's atmosphere. Okay. Okay. So this was related to the observational things. All the basic we have covered, most of the things. Now the question is, when first eclipse was observed. So first eclipse was noted by mankind around 3000 uh, before Christ. Okay, and it was considered as like shell of I mean it was recorded on the shell of tortoise. Okay, so in China it was found. So that was the first evidence. Okay, we are considering that is the first record of official record of eclipse, solar eclipse by human being. So different in different era. So people are observing eclipse. So initially it was considered that some kind of uh, demon is eating the sun, and this story is popular in all civilization, starting from Mayan, from to the Indian to Chinese, Egyptian, everywhere. Now we know it's a shadow. It's a game of shadow. I mean, moon shadow is falling on sun and all. Now, question is, what is benefit of observing the shadow? Is there any scientific benefit? Answer is yes. So, too many discoveries. Uh, happened during this solar eclipse. So two important observations we are going to discuss now. The first one is experimental evidence of for general theory of relativity. So everyone knows the year 1990, 1905, when Einstein has given the first theory, special theory of relativity, and the general theory of relativity, the second one, is given by Einstein. Now the question is, that theory was so surprising and shocking that he said gravitational force does not exist within two bodies like Earth, Moon, or Earth and Us. It is just some kind of space-time curvature is happening due to massive body. And he has also predicted the uh, like whenever light enters into or whenever light is passing nearby to the heavier object like sun, it will bend its path due to its space-time curvature. Now question is, it was surprising, and even many scientists could not believe on this because they knew that light does not have any mass. So since light does not have any mass, how can it get affected by gravity? So prediction was did, and no one could believe, first of all. So there was one scientist, Arthur Eddington. So he thought that we could test this theory using eclipse. So what he did first, on a particular day, he took one photo of stars. So this is not the real photo. This is the graphic is there. So and he noted down the position of different stars in sky. Okay, so he has selected a particular region where next solar eclipse is going to be happen. So wherever solar eclipse is taking place, so in that region he has taken few photographs, and he was just waiting for the solar eclipse. On the day of solar eclipse, he has again clicked the photos of the same region. Now you can see this star is at the same position, this star is also at the same position, but these two stars should have been placed over here, but they are actually observing away from each other. And this is the moon. So this is moon, and behind you can see the sun. So the star or stars which are very close to the sun or behind the sun are actually observing away from each other than the regular one. And here the explanation he gave. So what he said, since moon is present over here, so moon is blocking the whole sun. Now the actual position of star is over here. I would just click one. So here you can see the actual position of this star, the yellow one, and here you can see the red one. So this is the actual position of star. But whenever light is moving like this, it is bending while passing nearby the sun, and it is reaching to us. So if you just extend this, we feel as if light is coming from over here and that star is present over here. Similar to the another star, this one, one, the bluish circle. So the star is actually present over here, but but the light passing to the star is bending while passing near to the sun, and it is reaching to us. So if we extrapolate it, if we extrapolate this line in space, we can feel as if the star is present over here. So these are not the actual positions. So these two positions are apparent positions. So apparent means due to the path of light, we feel as if it is present over here, but in reality, they are there only. So this was the first confirmation of general theory of relativity. And after this theory, Einstein was world famous. Okay, so these two photographs taken by Arthur Eddington actually gave glorification to the theory of Einstein. And if you could remember the famous photo of Einstein, he is putting his tongue out and photographers click the photo. That photo was actually taken when photographers asked Einstein to give pose after proving this theory. So this is the first breakthrough in the physics, I would say, because this theory has proven that officially or scientific with proof, the experimental proof that gravity, whatever Newton said, the gravitational force and all, that does not exist. So whatever Einstein said, that was the reality, space-time curvature and all. So this is one of the major discovery or the experimental proof during the eclipse for physics. The second one is actually happened before this. So it was in 1868. So this is a scientist. The group of scientists came in Kerala. The region is Guntur. So from there they have taken some photographs and the spectrum also. So what is spectrum? Let me tell you what is spectrum. So just a minute. So whenever white light passes through the prism, everyone knows that. I hope everyone knows the prism. So whenever white light passes through the prism, it splits into several colors. So the upper one is the spectrum of sun. So this is a real spectrum of sun and few black lines you can observe. Now, instead of sun, if you put one source, the bulb which is filled with say sodium vapors, the street light, okay, whatever street light we see on the streets in Mumbai, so the yellowish lights are actually sodium bulbs or hydrogen bulbs or calcium bulb or neon bulb. So neon bulbs, if you know the tester which electrician use to check whether the light is not light is there or not, the electricity, so that type of neon bulb. So different bulbs are giving you different spectrums. So these are few spectrums are mentioned. Now what scientists used to do, whenever they take the photograph of say sun, they used to compare the sun spectrum with different element spectrum. So you can see these two lines. So here these two lines are known as sodium lines. So these two lines are due to sodium. Now you can see this one. This red line is due to hydrogen. So this one, the black one. So it means this black line came in this sun spectra because of hydrogen. So similarly, different lines you will get. This bluish is also because of hydrogen. This is also because of hydrogen. There are few lines because of mercury and all, neon and all. So you will get different lines, due to different spectra. Now, this scientists have taken one spectrum of corona. So I repeat, whenever total solar eclipse takes place, you can see the chromosphere, the light coming from chromosphere. So that spectrum or the atmosphere of sun. So that spectrum was taken by the scientist. Now he got all the colors. This one because of one element, barium. This one is because of magnesium, something because of hydrogen, sodium, and all. But he could not get or he could not associate a particular line whose wavelength is 587.6 nanometer with anything. So sodium was very close, 589, but 587 was not uh, getting connected or getting matching with any other element. So he said this line could be present because of an element which is not exist on the earth, but it is exist only on the sun. So in Greek language, we call sun as helios. So he gave this unknown element the name for this unknown element, that is helium. So this is nothing but extraterrestrial discovery of helium. So this is the first element which was actually which was predicted after this total solar eclipse, and 27 years after this discovery, the actual helium was made in the lab. So this is second most prominent. Actually, this was the most prominent discovery, and the second was that uh, the Einstein's general theory of relativity. So this is one of the most prominent discovery, that is the prediction of helium uh, element. So there are many other discoveries are there. I have discussed only these two. So I'm trying to discuss these two. I mean, discoveries in easier manner. If you will have any problem, you can ask me after this lecture immediately. So let us come back to. Let us stop this technical part and let us come back to the actual observation. So the things are do's and don'ts of viewing solar eclipse. Okay, so few things you need to follow strictly to prevent your eyes from any kind of damage. So first thumb rule is in general. So viewing the solar eclipse and looking at the sun with naked eyes. So even during the solar eclipse or even during uh, regular day, the seeing sun with naked eyes is very dangerous. So remember, you should not see the sun with naked eyes. It can cause serious damage to your eyes. So let us go ahead. So if you want to, if you still want to observe the solar eclipse, what could be Done. The very first thing is you can use solar goggles. Okay, all the solar filters are there, so you can purchase these solar goggles. You can wear it throughout the eclipse. Few people says that you can see the totality without goggle, but I never say that, because if you are doing it this first time or second time, we don't have that idea, and this phenomena is so eye catching and attention catching that we actually forget to wear it and all. So better see the whole thing, the whole solar eclipse with this uh, goggle. So what does this goggle do? So it actually blocks UV and IR radiation, and it permits hardly 0.0001% of visible light. Okay, so this is the best way to observe. Second, if uh, suppose sky is cloudy, so is it possible to see the solar eclipse? Now the question is, yes, you can see the solar eclipse, but you should not see. I mean, since the intensity of visible light is less, you won't feel any kind of harm. Okay, I repeat, you won't feel any kind of harm, but you cannot detect UV radiation. So this UV radiation straight for, I mean, directly goes in your eyes, falls on retina, and it causes damage. So seeing the solar eclipse during this cloudy sky is very harmful. So please avoid this. So even if the intensity is dropped drastically due to cloud, never ever look at sun with your open eyes. I mean naked eyes. Okay. Now question is, many people says we have good kind of sunglasses and we can see with this sunglasses. So it is not correct. 100% UV sunglasses also cannot provide 100% protection. It won't be able to block UV rays. So seeing with multiple goggles so that drop the intensity and everything, please do not do this. Use the proper solar goggle. Those are cheaper also. Okay, and nothing is costlier than your eyes. The second is it is discussed with many people by many people that we can observe this solar eclipse with the uh, this thing X-ray sheets. Okay, so X-ray film, or so, which is completely wrong. You should not use X-ray glass or X-ray sheet to observe the eclipse. Okay, so please avoid this. Next, so how to observe? So what not to do is done. That is more important. Now question is what to be done to observe this eclipse. So first is you can see the reflection in the still water in the pond. So those who knows the Marathi, so the Ram Janma Katha. So Ram wanted, I think Ram only. So Ram wanted to see catch the moon, and his mother um, came with a water, the still water, so he can see the reflection of moon. So this is similar phenomena. Here you are seeing the reflection of sun. This is a partial solar eclipse. You can observe this is a real photo in the still pond. So this is one of the um, better way. Second, the best way is using the solar eclipse. Now question is who can see the solar eclipse? Everyone can see the solar eclipse. So from newborn baby to like 80-year old person can see the solar eclipse. There are many misconceptions like pregnant woman cannot see the solar eclipse. It's not true. Even she can see the solar eclipse. The next one is pinhole camera. So I'm not discussing many things about this pinhole camera because we are going to conduct workshop on 25th itself. So our friend Aditya Desai sir will conduct the workshop. So pinhole camera is also one of the most effective and the safest way to see the or to observe the solar eclipse. So I would recommend that just instead of seeing the solar eclipse for few seconds, try to observe the solar eclipse. You will feel amazed with this. So this is the last slide. So thanking you everyone. I think I have finished lecture almost 15 minutes before. So fine. I'll keep some time for this question answer session. So you can ask me the questions if you have. Or if you want me to give so brief you about detail in any particular topic related to those slides, you can ask me.
Hello, can you hear me? Hello, can you hear me? Then-
Am I audible?
Yeah, you are audible. Hello,
Any question?
yeah. Uh, can you tell me the venue of this pinhole camera making of workshop? Hello, 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 hello.
Okay, so one question is there. What is the venue and timing for the workshop? It's Madam Kama Road, Dadar West, Savarkar Smarak. Okay, and it will start at 2 o'clock. Any other question?